story is just don't be lazy. Hey guys, welcome back to my YouTube channel. My name is Adora, and today I'm going to be talking about how I got A stars in IGCSE Additional Mathematics course number 0606. So this has been a long requested video, and I'm sorry it took me so long to make this. Honestly, the TLDR of this video is just do as many practice questions as possible, but in this video I'm going to break down the course fully and tell you guys how I revised, how I studied for it, my tips and tricks, my top strategies, as well as some costly mistakes that you have to avoid at all costs or else it's going to cost you a lot of marks. And my qualifications for making this video is that I got into the 97th percentile, I believe, when I took the exams in 2024 summer. So I would argue that my advice is valuable. Also, I'm currently doing an IGCSE tips video series. There's already so many other IGCSE subject tips videos that I have up on my channel, and you can just scroll through the playlist that I've made already from my YouTube page and see a guide for all the subjects that you take. So yeah, without further ado, I'm just gonna get right into it. Again, as always, I have my trusty iPad here and I took lots of notes on what I wanted to get through in this video. But first, I just wanted to start off with a question that I always get. Should I take additional maths? From what I know, I think it's just offered as an optional course at most schools, and it was at mine as well. Like, a lot of students took the course, but they could decide at the end if they wanted to take the actual exam, if they were confident enough for it. So personally, my answer to this question is it really depends on your level and your goals. So having this IGCSE ADDMATHS qualification is obviously really widely recognized across universities worldwide. And if you're trying to enter into a STEM field and major in a STEM field for university, it is often an entry requirement for a lot of universities. So if you're on the fence debating if you should take the subject or not, first make sure that you do check whether your major has this requirement and whether the universities that you're aiming for has this requirement.
Okay, while editing, I realized that a lot of unis might not have an IGCSE ADDMATHS specific requirement. However, they do have A-level or equivalent requirements for most courses, and many schools, as in high schools, may have internal requirements for the IGCSEs that you take in order to take those subjects in the A-levels. So basically, make sure that you check and know what you're doing.
Also, even if they don't have this requirement, I would still say that it's definitely a very valuable course to have, and it definitely helps you a lot in your later years of high school math in year 12 and 13. For example, now I'm in IB AAHL, which is the hardest IB math course, and having this additional maths foundation definitely helped me a lot, or else I probably would not understand most of what's going on. And if you're planning to take A-levels maths as well, I'd say it's the same thing. Having ADDMATHS is definitely going to be a very good foundation. Plus, you're going to have to learn all this maths anyway when you do end up taking those courses if you're planning to, so you might as well do it the earlier the better. Also, this course is just widely recognized to be one of the harder IGCSE ones, so having it on your transcript and your resume or whatever, it's definitely going to give you an edge over students that don't have it, because it shows that you're willing to put in the hard work to understanding like complex maths that has never been taught before. However, the cons to taking this course is that it's definitely obviously quite a big step up from the other maths courses. So from what I know, Cambridge offers 2 other math courses, and I took 0607, which is international maths, but there's also 0580, which is just mathematics that a lot of other people take as well. And just for both of these courses, ADDMATHS is definitely way harder, and there's going to be a lot more complex concepts. But as I said, it's definitely good to know them earlier on, especially because the harder courses like IBAAHL, it's really going to build on those skills that you learn in ADDMATHS. Even though it's like tremendously harder than ADDMATHS, yes, it can get a lot harder, but having that foundation was definitely really good for me. Okay, with that out of the way, I hope you're clear on whether you want to take the exam or not. So now I'm just going to get into the specifics of the course, and I wanted to start off with talking about the hardest topics and the things that you must remember at all costs. So in total in the ADDMATHS syllabus, there are 14 whole topics, but for the purpose of this video, I grouped some together so that it would be easier to talk about in a way that makes sense. So they're not in order of the actual syllabus order, but they're in an order that makes sense to me. And these are just going to be the hardest topics I found and the key things to remember for each. Okay, so starting off, we have number 1, all the algebra stuff, so algebraic manipulation and equations. And I would say that the hardest subtopics and skills here include factorization for quadratic and cubic expressions, simultaneous equations for linear and quadratics, as well as exponential and logarithmic functions. So for all of these subtopics, I wouldn't say that they're too hard compared to the rest of the course, but I'd say that they're definitely a big step up from what we previously learned in lower years, and they're going to just take some getting used to by just doing a lot of practice questions. But there are a few key details I wanted to point out for just algebra questions in general. And one thing that you have to keep in mind is that you have to be very aware of inequalities sign errors, because it's very easy to mix them up and it's going to cost you the entire mark and the method mark. And this goes especially for when you're deriving the critical values of a quadratic equation. Secondly, a key thing to remember for logs questions is that you can never take a log or a ln of a negative number. So if you have a negative number in there, just know that you got it wrong and you have to redo it. And the third thing is just remembering your index rules. Now, you learned this a little bit earlier on in the course, and it's really easy to forget this stuff when you get to the harder stuff and like your mind just doesn't think about the quote-unquote easy stuff anymore. So this just means that indices with brackets should be multiplied, whereas indices without brackets should be added. And I'm going to put an example up on the screen because this is definitely something that is also very easy to get wrong. Okay, the next subtopic of questions I grouped is functions and graphs, and this actually encompasses quite a large amount of the syllabus. So this includes stuff like sketching and transforming graphs, finding inverse and composite functions, as well as solving inequalities graphically. For this topic, a lot of these question types repeat over and over throughout the past papers. So again, just do as many past papers as possible, right? But for this, I just wanted to point out some key things, which is 1, don't get confused between inverse functions and taking the derivatives of functions. So inverse functions should be like f to the -1 notation, and derivatives of functions are f with an apostrophe. So make sure that you remember that and don't mix them up. And the other thing is that I just wanted to point out how you should be drawing your graph, since I think graph drawing questions will always come up at least once every single year. So always just have this graph checklist in mind every time you are asked a question where you need to draw a graph. And this includes axes labels with a clear scale. Label your axes X and Y because sometimes they actually do award marks for that. And also make sure that you have the minimum and the maximum of the scale labeled clearly. Secondly, you have to make sure that you do indicate your X and Y intercepts on the graph. Thirdly, you have to have the correct line behavior and shape. So this includes indicating the turning points, which are the maximums and the minimums of the graph, as well as the endpoints, especially if it's limited on a domain or range, and also labeling the roots clearly on the graph, which I realized I repeated myself there with the x-intercepts, but you get the point. You just have to label all like the key distinct features of the graph very clearly. And the last thing to remember is to have the correct range and domain, and they will usually define this in the question, or else they might ask you for it in the question. So just make sure that that is as clear as possible, because you don't want to waste time drawing irrelevant parts of the graph, and you also don't want to be missing the part that they're actually asking for. Okay, next, the third section of topics that I wanted to talk about is trigonometry and circular measure. Now, this is also a new topic that I thought got a lot harder when I started ADDMATHS with the unit circle and all that. It's definitely a little bit hard to understand at first, but once you do enough questions, you do get the hang of the unit circle and you kind of end up just memorizing the values and everything. But yeah, this topic includes applying the sine and cosine rule, radian measure calculations, as well as graph transformations of trigonometric functions, and I thought that those subtopics within that category were the hardest. But I would say that the key things to remember for this topic is that you have to read very carefully in the question if they require you to answer the question in degrees or radians form. Now, it's really easy to get this wrong, and you're gonna have to do the question all over again in the other form if you mix it up. So just remember to read very carefully, and also that the conversion is that pi radians equals 180 degrees. And I thought that an easier way to remember this while you're converting is that the degrees will always usually be bigger. So if you have something in radians, for example, you divide it by pi and then times 180 degrees because you want it to be bigger. And also with these conversions, make sure that you're always keeping track of what units the numbers that you're writing down are, because it's going to be very easy to confuse the two. Okay, the next thing is when you have questions in trigonometry for finding the angle of something using the unit circle, make sure that you are using all the relevant quadrants of the unit circle to get all the values that you need, because most of the times the answer is going to be more than one value and it doesn't tell you how many values you're looking for. So you have to be very diligent in getting every single quadrant of the unit circle and eliminating answers that don't make sense as well and aren't in the domain. Okay, and the third thing to keep in mind is for just circular measure questions in general, is that you should always keep more digits in the decimal points for calculations leading up to the final calculation, because in these questions especially, if you scrap digits from your calculator too early, it can result in a miscalculation of your final answer, even though you had all the working there all along. It's just that you're missing the digits, so it ends up being a different number. Even though there is just a marginal difference, it's just good practice to keep a reasonable amount of digits so that your answer does not impact the final answer, if that makes sense. And then my next thing is that sometimes you are required to draw the sine, cosine, and tangent graphs. I feel like usually this always comes up once a year as well. So just make sure that you memorize all the key details of these graphs, since it's something that you easily forget about while revising, because you can just easily generate it on your calculator. But just remember the periods for each of these graphs. So sine and cosine graphs have a period of 2 pi over b, with b being what's before x, like in sine x or cosine x. It's going to make more sense if I put an equation on the board. And then for tan graphs, the period is pi over b. So just keep that in mind and don't mix those two up, so that it's like a lot easier when you do those kinds of questions. Okay, next for calculus questions, the hardest topics that I found that you should keep in mind to keep revising is finding derivatives of polynomials, exponentials, and trigonometric functions, which might not follow one of the standard formulas. And also the applications of differentiation, which includes finding the maximum and minimum, as well as the rates of change and like the kinematic stuff. And also there's basic integration and area under the curve. And I think this course is definitely a lot of people's first introduction to calculus, at least it was for me as well. So don't worry if the topic doesn't make sense to you from the start, because it usually takes people a while to get the hang of it. But I promise you, it's just like doing a lot of questions. You just get used to the style and your brain gets used to all the like derivative and integration questions. But the key things to remember for calculus type questions is that the sine x and cosine x for differentiation and integration, they're super easy to mix up. So just make sure that you have the negative or positive sign correct for what you're trying to do. Also, a very important thing is that for indefinite integration, do not leave out the arbitrary constant plus c, because a lot of the times you actually do get a mark for just writing plus c in your final answer. So just make sure that you don't forget about it, because it's a crucial part of the equation. And it's really easy to just discard it, even though it's like a crucial part of the answer. So just make sure that you do keep that in mind. Next, for vectors and coordinate geometry, this includes finding magnitude and direction, vector proofs in geometry, and midpoints, gradients, and equations of circles. I don't think that this topic was too hard because it's really, really repetitive, but just make sure that you know the key terminology. And what I wrote down is just that make sure that you know what a unit vector is. A unit vector is a vector of length 1. So how you find it is by dividing that vector by its magnitude, and the magnitude is the root of the squares of what make up that vector. I'll put up the formula on the board again. And yeah, there's a few questions relating to that, such as when you're given a vector and you have to find a vector that's in the same direction but to a different length. And how you do that is by first finding the unit vector and then multiplying it by that length k that they're asking for. And then next, for probability questions, permutations, and combinations, the key thing here is just to not mix these two up. And how I remember them is that permutation is where order matters. So for example, if you have to choose the order of the top 3 winners, that's when order matters. Whereas for combinations, you don't need order. So that's for stuff like choosing teams out of people, and that's where you'll need it. Okay, sorry about the lighting change. I had to change angles because it got dark. And it's getting dark so much earlier in Hong Kong because winter is coming. Okay, but the next section of this video is going to be how to study for additional maths, and I tried to break it down. So first, making notes, I would say that you should make it by topics according to the syllabus, as I say in all of my IGCSE videos. But I think the key thing here is that you should make notes of every single topic, because I realized that as I was going later into the course, I was forgetting things from the earlier topics and like the easier topics. So I would say that make sure you have the notes down for the previous topics as well, just so you don't forget them. So for notes, make sure that you include the general formulas. I would also say that it would be really good if you included like their logical steps to solving common problems, and I'll put an image up on the screen of what mine look like, but I just write in like English words of how I would do a general problem of the same like question type, and that's how it makes more sense in my brain, and I can just apply that same like sequence of steps to future problems and get the answer right. And another thing that you can do is put in worked solutions of really common problems. And I did this as well, where I just wrote down the answers on paper, like the full method of how I did the algebra and everything. And then I scanned it and I put it into my notes digitally. And I thought that this really helped because I could actually like retrace my steps when I was revising and see exactly how I do the algebra, especially as I said, I'm really prone to forgetting this kind of stuff. So yeah, that was definitely a good strategy that I would recommend. The other thing is that if you're having difficulty with solving questions, there are plenty of YouTube video tutorials online, but I would say that if you do follow those, make sure that you actually follow those and you're not just passively listening. So if you do those, make sure that you have a piece of paper out and you're like following the questions, algebra steps as it's going, just so that it actually retains in your mind. And then afterwards you can actually take a photo of it and scan it and put it up in your notes so you don't forget it. And finally, the best strategy is to do as many past papers as possible and under time conditions. So you have to get used to the exam layout and the types of questions as well as the time limits in the actual exam, which is why I just recommend just doing as many as possible. Try to aim for at least 5 years. And in each of the 5 years, there's going to be like different time zones. So it ends up being a lot more than just 5 sets of past papers. It's like, yeah, it's just like a lot more. So yeah, just do as many as possible and kind of space them out. Like have a schedule where you write down which day you're going to do what past paper exactly, so that you hold yourself accountable for it. And through doing these, you can just find out what you're good at and what you need to work harder on. And just doing as many practice questions as possible, it will just help you feel a lot more confident and ready for the real thing. Okay, now I'm going to run through the 8 costly mistakes that you have to make sure you avoid at all costs that I've compiled. So 1, not understanding the question fully. Make sure that you read every question very carefully, underline the keywords, and make sure you know what the question is asking for, or else you're going to have to do it all over again, and it's so much more worth it spending more time to understand the question rather than having to scrap all your answers and do it all over again. The second mistake is skipping steps in your calculations. So you should always show your full working to secure all the method marks possible. If you do run out of room for working on a question, you can request for an extra piece of paper during the exam, and you just have to write down specifically which question you're appending that piece of paper to. And this is really important because you get no marks if you just write down an answer without having any working, and it's so not worth it, especially when you know the working, you're just too lazy to write it down. So moral of the story is just don't be lazy. And the third mistake is having poor time management. So make sure that you allocate your time very effectively during the exam. Keep in mind that both papers are 120 minutes of 80 marks each. This might change in the future, but currently that's what it is. So this means that you should aim to spend 1 to 1.5 minutes per mark to make sure that you have time to complete the paper and time to go through it all over again at the end. And at the end, just keep on going through it and triple checking your answers. Okay, the fourth mistake is not practicing enough past papers. So as I said before, and as I always say, not having enough timed practice is going to impact your confidence in the exam and your speed. And doing as many practices as possible is just going to improve your efficiency and your familiarity with these question types that keep getting recycled and recycled. Number 5 is not memorizing your formulas. So the question paper is going to give you a list of formulas. However, not all of the formulas required are listed on that page. So make sure that you do memorize the key formulas to just save time during the calculations, even for the formulas that are already listed on the page, but more importantly for the ones that aren't, just so you know that you have like that as a fallback. And I'll put it up on the screen as well, but it's just like the basic geometry and trig functions as well as some basic algebra functions, but it's missing a lot of the other functions, such as the calculus equations, which are definitely very important to remember. Okay, next, mistake number 6 is misinterpreting graphs and diagrams. So make sure that you carefully look at the graphs and diagrams that are given to avoid errors, which come up in the function questions or the coordinate geometry type questions. Next, mistake number 7 is not looking at the total marks awarded for each question before answering the question. And this number of marks will tell you exactly how much working they're expecting. So if it's just a 1-mark question, that basically means you only need the answer, if not just like a short line of working. If it's like an 8-marker, obviously that's going to be lots and lots of steps that you're going to need, and you should aim for like a full page of writing, for example. So yeah, this should help you not waste time on the shorter questions and spend your time effectively on those longer style questions and show that sufficient amount of working that you need. And finally, mistake number 8 is not writing your answers to the correct level of accuracy. Now, at the front of the exam booklet, it tells you specifically the accuracy guidelines that your answers should be in. So typically all your answers should be in exact form, which means like a fraction or like a third or something like that. However, if the question indicates otherwise, then follow that. Usually that would be 3 significant figures, and for angle questions specifically, it would be 1 decimal point. So just make sure that you remember that, because you do get marks for the accuracy given, on top of having a correct answer as well. And yeah, that concludes my IGCSE ADDMATHS tips video. I really hope that this helped you, and if you have any questions, make sure to leave it down in the comments below, and I'll try my best to get to them. Also, big shout out to my top commenters these past week. If you want a shout out in next week's video, make sure that you leave a comment. And also just wanted to plug that I have a short film out on YouTube about what it's like growing up with AI, and I would really appreciate it if you could check it out and leave some support for it in that video so that it doesn't flop, because I really worked hard on it. And yeah, as I said at the start of the video, I do have a playlist on my channel with all of my IGCSE related tips videos and just study tips videos in general. So make sure to check those out. And obviously also make sure to subscribe to my channel, leave a like on this video if you liked it, comment other video ideas or anything else that you want to see from me. And yeah, thank you guys so much for watching, and best of luck on your ADDMATHS exams. Bye!